Okay, for question 35, it says the computer valued at $6,500. So first thing, looking, this is an exponential model. A is the initial value, also the y-intercept. The initial value is 6,500, so we have 6,500 here. It says that it's depreciating at a rate of 14.3%. The growth factor, B, or decay factor in this case, B is equal to 1 plus R. The rate of depreciation is 14.3%, so that's a negative 14.3%, which as a decimal is equal to a negative negative 0.143. So in this case, B equals 1 plus a negative, or just simply 1 minus 0.143. Okay, and so what that gives us is 0.857 raised to the x. So there we have our growth factor or decay factor of 0.857. We have our initial value of 6,500, and that is part A. We have just written a function that models the value of the computer. Okay, just keep in mind 6,500 times it's worth roughly 86% of what it was after each year. So we're taking this total and we're multiplying it by 86%. Okay, now it says find the value of the computer after 3 years. So all we have to do then is plug in 3 for x and solve. So we have 6,500, 0.857. Having a hard time with my 5 here. 857 raised to the third power. And that is, y is approximately $4,091.25 after 3 years. Okay, so that's 35. Now for 37, it says to find the annual percent increase or decrease that the function models. And the function is y equals 1,298 times 1.63 raised to the x. Remember, b, which is 1.63, is equal to 1 plus r. So to find the rate, b, in this case we know is 1.63. So that equals 1 plus r. Just subtract 1. So we get a rate of 0.63. So r is a rate of increase of 63% annually. So the answer for 37 is 63%. And last but not least, we have 46. And 46 says for each annual rate of change, find the corresponding growth or decay factor. The growth or decay factor is B. B is 1 plus R. On 46, the rate is plus 70%. So that's 1 plus 0.7. So B, the growth factor, is 1.7. And that's how you solve questions 35, 37, and 46 on the Advanced Algebra 2 homework.